Okay, so section 6.4, solving special systems. Special systems are parallel lines or coincident lines or intersecting lines. We can really add in there. And we look at these lines. Consistent lines are lines that intersect, and so we can either have one intersecting line, or we can have two lines that are right on top of each other, and those would be considered consistent lines. Inconsistent lines are parallel lines. They have no intersection. So we're first going to make a distinction between consistent and inconsistent. And then once we make that decision, we're going to talk about consistent lines being broken down further as dependent or independent lines. And dependent consistent lines are two lines that lay right on top of each other. Consistent independent lines are lines where there's one solution only. So we have, if we look at a graph and we have a line that looks like this, there's one intersection. So this is consistent because it intersects. And it is independent because it only intersects in one place. These two lines don't intersect, so they are inconsistent. And we don't label them as anything else other than that. And then we have this system of equations where the lines lie right on top of each other, and those are consistent, dependent, and they have an infinite number of solutions. Let's go back. This only has one solution. And the inconsistent has 0 solutions. Okay, so how do we tell whether our graph is consistent, independent, inconsistent, or consistent, dependent? So let's start and look at some of these graphs, or some of this. We have two equations here. The first way that we can show that these two lines are consistent, inconsistent, or dependent and independent is to go to Desmos and graph them. So let's go to Desmos. And we're going to go y equals x plus 1. We get that line there. And the other equation that they gave us is negative x plus y equals 3. And we get that line. And we can see that those are two parallel lines. So there's no solutions, and they are inconsistent. Okay. The other way to show this is analytically. So we did it graphically. And now we're going to do it analytically. So in order to do it analytically, we're going to look at slopes. That's going to be the first thing that we're going to look at. And if the slopes are the same, those are going to be either parallel lines or the same lines. if their slopes are different, those are going to be intersecting lines. They'll have one solution, and they are considered consistent, independent. So the slopes are the same. Then we have to look at y-intercepts. If the y-intercepts are the same, then they're the same line. And they have an infinite number of solutions. And they are consistent, dependent. And if the y-intercepts are different, they are parallel lines, and they are inconsistent. So that's kind of what we're going to do analytically. We're going to look at those. So I'm going to go back over here and I'm going to solve each equation for y so that I can look at the slopes and the y-intercepts. So the first equation is already solved for y. So the second equation, I'm going to take and move the x term over. So when I go across that equal sign, the x becomes positive. The 3 stayed on the right-hand side, so it stays positive. So I have these two lines. So now the slopes, look at number in front of the x. So in both cases, the slopes are 1 because it's 1x. The y-intercepts are 1 and 3. So this tells us parallel lines, no solutions, inconsistent. Okay, so let's look at another couple examples here. Okay, just want to make sure my writing didn't go away. So if I have this equation, negative y equals 4x minus 1 and 4x plus y equals 2. I'm going to first solve this for y. It's not solved for y, it's solved for a negative y. So to get it solved for y, I change the signs on everything. So positive y equals negative 4x plus 1. I'm sorry, this should have been a plus 1 to start with, and this should be a minus 1. How's that? Starts with a plus 1, converts it to a minus 1. Then this one, we bring the x term over to the other side of the equation. It becomes negative, and we have plus 2. Slopes are both negative 4. Y-intercepts, negative 1 and positive 2. Therefore, those 3 marks mean therefore they are parallel lines, inconsistent, and 0 solutions. One more example. Negative 9x minus 3y equals negative 18. And 3x plus y equals 6. So I'm going to take and solve for y. I move the x term over. I get negative 3y equals positive 9x minus 18. I divide everything by negative 3. I get y equals negative 3x plus 6. The second equation, I move the x over to the other side. It becomes y equals negative 3x plus 6. Same slopes, same y-intercepts. So these are the same line. So they are consistent, infinite number of solutions, and they are dependent. So that lesson 6.4, that's what we have to talk about: consistent, independent, consistent, dependent, and inconsistent. Those three terminologies. So, and they all go back to, are they parallel lines? Are they intersecting lines? Or are they lines that represent the same line? They lie right on top of each other. So those are your special situations, special systems. And if you have questions, email me.